Okay. Again, yes, good morning to you. Welcome, everyone. We're going to go through some training objectives here with regard to BPI 1200 and OSHA in your toolkit. So I want to make sure we understand, everyone understands here the disclaimer in that we're providing, especially this OSHA information, as an educational resource, and we're not possible for interpretation of the standard. So if you do have any questions about that, you'll have to seek other advice. We can provide some instructional, educational information again, but not specifics to your situation because we don't know your situation. If you do wish to ask a question, I will attempt to answer as many as I can. Please use the GoToMeeting control panel on the side with the orange arrow. Pop it out by clicking on the orange arrow. Click your question box, the question panel. It'll drop down, and in this area here, you can enter a question, which will come over to me. With regard to BPI CEUs, there's up to one CEU for the class. What we mean by up to one is BPI can make the call as to whether or not one gets granted depending upon attentiveness factors. Frankly, we haven't seen that to be a problem, so we'll just say one CEU for this class. Really want you to stay on the screen, stay attentive, and paying attention to the session. In terms of when do you get your CEUs, TruTech will submit a report to the BPI portal within less than 72 hours. So it should go up and the class will be closed out and everything will be in place within less than 3 days. Contact TruTech first if you have any questions because it's up to us to do the reporting. That's the way the system works right now. If you're not familiar with TruTech tools, our tagline is quality tools, essential support, and we really try to put those two things together with knowledgeable people, having the right products, getting those products out to you quickly, offering them at affordable prices, and doing different programs like free webinars and gift certificates and things like that to keep you rolling. We really want to help you learn and do the correct work and understand what you're going through in terms of the work that you're doing. So it's a mutual objective here. Just also want to let you know, we released a press release today. TruTech Tools was nominated or put into the top 5,000 by Inc. magazine, the top 5,000 privately growing businesses in the United States. We ranked at number 3962 out of all privately owned businesses in the United States. So we're one of the fastest growing businesses out there. And it's really, it boils down to our team that gets us there and our customers that get us there. So again, we appreciate what you do for us, and we hope you appreciate what we do for you. We do carry 50 popular brands of products. These are our 50 brands of products, actually more than that, more like 60 or 70. These are our most popular brands we tend to sell a lot of, and we have really good relationships with the vendors that develop these products. So we're a good channel to feed back to them. If you don't follow us on Facebook or LinkedIn or Twitter, you should, because we do have a lot of communication out there. Our newsletters, we really try to do our part to keep the industry moving ahead. Our key product areas, if you're not familiar, this is basically sort of our key product list. We do combustion emissions testing. We do have calibration of Bacharach and Testo combustion analyzers, airflow and measurements, safety, and OSHA. So we'll be talking about more of that today. And we all have a new category called For the Home, where we're bringing in low-cost particulate, carbon monoxide monitors, air quality monitors, things you might want to look at in terms of the building performance spectrum, which is really rapidly moving into indoor air quality. So in terms of a background, BPI standards, a standard provides the basis for ensuring that work is done uniformly. It's done the same way, using the same methods in a repeatable fashion, and that's what really helps to produce the foundations of a good industry. Standards are enforceable if they are referenced by an authority having jurisdiction. The standard BPI 1100, you may not have heard of that, but there's one called 1100. That tells you what to do. That tells you what the objectives are of a building performance audit. And BPI 1200 tells you how to do it. And that's where TruTech comes in. We are the ones who know about how to do things and what tools to use, and that's the whole purpose of this webinar. Now, one thing to keep in mind, your authority having jurisdiction, your boss, whoever is paying the money for the work that gets done, may call out more than just standard work. So we want to make sure we correctly portray this in that the BPI standard calls out certain things, but you may be doing more work than the standard, which is okay. Your authority, whoever is designating the work you do, may call out for more work to be done in excess of what is actually in the standard, and that's okay. For OSHA, background on that, it's the Occupational Safety and Health Administration. It's a division of U.S. Department of Labor. One of the key things here is it's about an employee-employer relationship. And this is where you'll want to go back to, and we'll give you some resources to go back to the FAQs, the frequently asked questions, on the OSHA website. And you can find out more about, are you governed by or must you abide by OSHA rules? And it's really about employee and employer relationships. The employers are responsible for providing a safe workplace that doesn't have hazards present. They must find and correct any safety and health problems. And they must first try to eliminate or reduce the hazard by making changes rather than relying upon protective gear. So that's a really important concept here that kind of echoes through this whole OSHA concept, is you want to eliminate, reduce, remove hazards. That's the goal. You don't want to be working in hazardous conditions where you have to be sort of on high alert that something doesn't go wrong and imperils life and limb. The BPI 1200 is an ANSI standard. That's the American National Standards Institute. It was released in May of 2015. You can actually download it from the BPI website. And I made up a quick link here if you wanted to use that. You can, of course, go to the BPI site. This takes you to the BPI site. It's bit.ly/BPI. It's got to be in uppercase, -1200. So bit.ly/BPI-1200. That'll take you right to the BPI 1200, which is going to be one of the main topics we talk about today. So an ANSI standard, and I have a picture here of sausage being made, and that's often the reference used when we talk about things that are governmental or jurisdictional or legal or things like that. But there's actually a procedure that's used, and that is also referenced here in this short link. If you want to see it, it's on the BPI site. It tells you how they went about making this standard. It's a consensus standard. That means many parties have to agree, and it's supposed to take, BPI's done a great job of putting together various people from the industry to come together and take a look and have oversight in the standard and make sure it's compatible with all elements of the industry. It does also reference other standards that are out there. So in essence, it does not reinvent the wheel, but it uses the wheels that are out there to move things forward. It's very tough work. There's many people involved in the committees. So there's a lot of respect that has to go the way of BPI and the people that are involved in these committees. It's not an easy thing to do. There's a lot of back and forth. I'm on some of the technical committees, and there's a lot of discussion, which is all done with the intent of improving the industry. This is a screenshot from the table of contents from the BPI 1200. We'll be talking about two specific sections. You can see there's an awful lot of detail here, and we're going to spend probably over an hour talking about just two sections in this standard. When it comes to standards, you really have to understand standard making language. This is something I want to make sure you're clear on. But the word shall indicates a mandatory requirement. That means must. It must happen. May indicates permission. It's neither a requirement or a recommendation. It's something you could do. Should means it's recommended. It's not mandatory, but it's good practice. So there's all kinds of levels here in the verbs that are used in a standard. The standard in the BPI 1200 standard, it actually states, it defines the minimum criteria for conducting a building science-based residential energy audit and related diagnostic tests. So this is the minimum standard. Going back to the authority or whomever you're doing the work for may require in excess of the minimum, and that's cool. That can happen. So just want to make sure you understand things that meet the standard. Some things may go beyond the standard, and that's okay. There's also normative versus informative appendices. Normative are really telling you what to do. Informative are just providing background information. There are also interpretations of the standard. I've seen, I think, one or two for the BPI 1200 standard. So if you go to their website, you'll see People have asked very specific questions, and BPI felt it was necessary to actually give an interpretation or sort of write a little letter to explain that particular question. One of the terms used in BPI 1200, one of the devices is called a CGD. It's a combustible gas detector. So the combustible gas detector, as stated in the standard, must be classified to UL 913, which means intrinsically safe, and intrinsically safe for use in various classes, divisions. So this is various environments that it can be used in. So a lot of forethought was made in terms of what the right device would be and what the application would be for that device. What Class 1 means, Class 1 is for gases, basically, hazardous gases. Class 2 is for dust, and Class 3 is for fibers. The energy levels required for dust to combust and be explosive and fibers are much higher than Class 1 intrinsic safety requirements. And this is usually the case that having a Class 1 approval automatically gains Class 2 and 3 approval because of the intrinsic safety requirement being sort of the most stringent for Class 1. So basically, if you have Class 1, which are gases, you already surpass the Class 2 and 3 requirements, since combustible gases are the most easiest to burn or easier to burn than dust and fiber concentrations. The statement that it must be intrinsically safe means intrinsically safe definition is it's incapable of releasing enough energy under normal conditions to cause ignition of a specific atmosphere. So this comes right from the International Standards Association, or Instrument Standard, ISA, I believe it's Instrument Standards of America. I'll have to double check that, it's been so long. That's the standard definition for an intrinsically safe product. It limits the amount of power that goes through the equipment and can reach the gas in the atmosphere, which would cause the potential for an explosion. Something to be really closely aware of is intrinsic really means, in this case, by design. So that emphasizes the product must be used as designed. Some products say must be used with a certain type of battery or equivalent. If you don't follow that procedure, you may be taking it out of its design criteria and no longer having it be intrinsically safe. Or it may require you to use with the covers on and covers screwed down. That is an intrinsic or by design element, so you do have to comply with that in order for it to be intrinsically safe. So it's not just the product by itself, but it's how you use the product that has impact here. So what's necessary for a fire or explosion when we're talking about intrinsic safety? It really goes back to the combustion triangle. There needs to be fuel, sufficient oxygen, and a source of ignition for combustion to happen. It has to be at the same time and the same place and in the correct quantities. So the right amount of fuel to oxygen and the right amount of energy in the ignition. Now usually the device, the intrinsically safe device, is what controls this aspect of ignition, the thermal or electrical energy present that could cause this ignition to happen. And it's your environment where you have the fuel and the oxygen going on. And we'll be talking more about oxygen concentration measurement and fuel concentration measurement, and you kind of see how all of this fits together in terms of explosive protection. So an intrinsically safe product assumes that there's a dangerous amount of fuel and oxygen, a dangerous combination, a dangerous mixture, and we'll talk about what those mixture levels are in a few minutes. And the intrinsically safe product will limit the amount of ignition energy so it can never cause an ignition. So it's assuming things are bad out there in the world, but it's never going to introduce any kind of power that could cause this ignition to happen. The combustible gas detector, and these numbers here are directly from the BPI 1200 standard, so you can look them up and reference them, requires a variable tick rate. So a combustible gas detector shall have a variable tick rate. It could be with an adjustable dial, thumb wheel, or a keypad, a digital adjustment, or something like a resettable tick rate. It must, for the tick rate, for the gas leak detection part of its job, it must be measuring relative, not absolute concentration. In other words, detecting more here and less there. So it's in the leak detection mode. And there's actually a couple modes for the combustible gas detector we should be aware of. So a product like here, the Sensit Gold, it has a button here which allows you to reset the tick rate, or the Sensit HXG2D. This allows you to reset the tick rate here. So this is what it means in terms of a keypad adjustment. Another requirement, which is sort of now reduces the list of compatible or compliant products, and we'll talk at the end here about what those compliant products are, is 7.1.1.3, as the product must have an LEL alarm. It must be capable of providing a digital display of the percent of lower explosive limit of the gas, or provide an alarm when detecting gases that are above the 10% lower explosive limit. In a minute, we'll talk about why that level is important, but this is a requirement by BPA 1200 placed on the equipment you used if you're going to be compliant with the standard. The LEL, or lower explosive limit, for methane is 5% gas, which is 5,000 parts per million. And for propane, it's 2.15% gas, which is 2150 parts per million gas. So there's a measurement here, and if you're familiar with combustion analyzers or CO meters, you're starting to hear some of the similar terminology about ppm. But the explosive limit we'll talk about here in just a minute. But the basic thing to take away here, if you do not have an LEL display or an alarm at 10% LEL, it's a no-go for your combustible gas detector. It cannot be used and be compliant with BPI 1200. So what's a characteristic of a combustible gas? You'll see in the chart over here, we talk about the concentration, the percent of the gas in air. In the green area, it's too lean for combustion. There's not enough gas for the amount of oxygen present for combustion to be ignited. In the red area, it will support that. And then you can actually get too much fuel to the air, and you'll get into the yellow area where ignition won't happen. The dangerous aspect here is when you rise above the upper explosive limit, if the air clears, it'll drop back down into the danger zone and support combustion. So the goal is always to stay below the lower explosive limit, and in fact, most standards are written, as the BPI 1200 is, to have it at 10%, or a very, very low level. And that's because situations can change very rapidly. So above the upper explosive limit, it's too fuel rich to burn, the yellow zone, but that doesn't mean it's safe. That's a caution area. Red, within the explosive and flammable range, there's correct concentrations of air to oxygen that a source of ignition, once introduced, could cause an explosive combustion. In the green zone below the LEL, or sometimes it's also called LFL, lower flammable limit, it's too lean to burn. There's not enough fuel present for the oxygen. And basically LEL and lower flammable limit, those are equivalent terms, but most of the time you're going to hear the term LEL, lower explosive limit. So measuring a gas concentration is typically done in parts per million, or percent of LEL or percent of UEL. Now the actual gas concentration is specific to the gas, and parts per million is equivalent to ppm. There's an equation there between the two. But the LEL is different because different gases have different explosive characteristics. And normal oxygen, we talked about the 5% methane and 2.15% propane. Those are the lower explosive limits for those two gases. They are different. They will differ for different combustible gases. Another aspect is calibration requirement. The device, according to the BPI standard, must be calibrated or operated in accordance with the manufacturer's recommendation, with documentation traceable back to the device. So you need to know that this device is being kept within performance range. We'll be talking about different products, and these are just facts. These are not in any way meant to slight any particular brand of product or name a product, but the Leakator 10 by Bacharach is a no-go because it does not require calibration at regular intervals, means it cannot be calibrated. So my interpretation with regard to the BPI standard is a Leacator 10 is a no-go because it cannot be calibrated. We'll also see another reason that it cannot be used in a moment too. Must be able to zero out the ambient conditions with your combustible gas detector by adjusting out background levels by using a thumb wheel or a button. The case of the two products we looked at before, there is a zeroing button which allows you to adjust out those background levels. So again, this helps in the gas leak detection mode. One thing I did want to talk about is odorants in natural gas. Sometimes people feel like, well, I can smell gas, so why do I need to have a detector? I can tell before things get dangerous. Well, methane, which is the predominant component of natural gas in the United States, unless, of course, you're using propane, methane, so the natural gas system, is not cannot be detected by smell in its natural state. So odorants are added in the processing system. Methyl mercaptan is the most commonly used odorant, and it produces a rotten egg smell. And that odorant is detectable by most people at fairly low levels, the odorant itself at 1 to 3 parts per billion. And some people may even smell or detect at 0.1 part per billion of the odorant. So a little bit of odorant is added to the gas as it's moving through the system. Usually it gets added at a certain point in distribution, so it may not always be there. However, noses are not detectors. Even big noses, like the one on the screen here, they are not detectors. They cannot be relied upon for accurate determination of concentration. And there's a physiological thing that happens called olfactory fatigue, where if you smell a smell for a certain period of time, your nose can get used to it and you're no longer detecting that level. So you need to be very careful and not assume that if you smell gas, that you know for sure that there is none there. You may not smell it. So what do you need to look for in a combustible gas detector that's going to be compliant with the BPI 1200 standard? Going back, we're going to recap here. It's intrinsic safety, which means UL 913 Class 1, Div 1, Groups A, B, and C. The Class 2 and 3, again, we talked about how that is already covered by 1. An adjustable tick rate. And this is one of the sort of the limiting characteristics of the standard, providing a display or an alarm above 10% LEL. You'll get a host of meters that will comply with the first two parts, but this third part really narrows the field down to just a couple. Documentation of calibration is essential. Zeroing ability, that's also something that can be done by a lot of meters. So really it boils down to the providing the display or an alarm above 10% LEL sort of rules it down to just a few detectors that are compatible with the standard. There's also, for a period of time, and this was maybe 18 months ago, but I heard it a lot, people were confused when they heard 10 ppm detection threshold was being used. I believe in some states were requiring that they had to have gas leak detectors that were sensitive as 10 parts per million detection threshold. And some people were confusing that with 10% LEL in terms of alarm or display level. And those two are very different. So detection threshold and LEL readout or alarm are two different things. You can have a sensitive detector, but it doesn't display any level on it. So there's a difference here. I want to make sure people understand that difference. Now, moving on to carbon monoxide, the 7.1.2.1 part of the standard calls for a range of 0 to 2,000 parts per million. So the equipment has to display up to that level. And looks like someone has got a puppy farm going here raising Monoxer 2s. That was a product I was involved in development of at Bacharach. That's an older product. Even that product was available to display up to 2,000 parts per million. However, there's some additional requirements placed by the standard that would rule out products like the Monoxer 2 and its successors. That element that rules them out is the next topic we're talking about here, which is CO air-free. So the device that you use for CO air-free testing must be capable of calculating and displaying digitally the CO air-free concentration, or have displays of O2 and CO such that you could do a manual calculation of CO air-free. That last part of the sentence usually is never employed because most people do have combustion analyzers which measure the CO and the O2, so they're able to get that calculation. It's done digitally by the device itself. So normal air is 20.9% oxygen, and the CO air-free calculation usually tops out at almost 10,000. CO air-free sometimes is also called CO undiluted or CO undilute or undil. It's basically removing the impact of the diluting air from the calculation of CO. And this is from my webinar on combustion analysis. And we're going to talk just a little bit here about how to illustrate sort of the concept of why is CO air-free of interest. The stoichiometric line here is the point of perfect chemical balance, where you have just enough air or oxygen going into the system so that you can achieve good combustion. The flue gas concentration of different components is over here. It rises going up on the left, and the lower scale is increasing air or oxygen going into combustion. On one side of stoichiometric, there's incomplete. On the other side, there's complete combustion. So as you get more air going into the system, there's not enough air for complete combustion. So your combustion analyzer is not reading any kind of levels of oxygen until you get beyond the stoichiometric line. Okay, this is just a basic principle of combustion analysis. The carbon monoxide level usually sharply declines as you move through incomplete combustion and through complete combustion, and because things are not always the same and there's a lot of kind of randomness and chaos in combustion, you will get some CO levels diminishing as you go to higher levels of oxygen. But basically, CO is getting lower and lower as you move towards more air being introduced in combustion. The CO air-free calculation actually does a mixture between the CO level, we'll go back one slide, the CO level and the oxygen level, and we'll plot a line which is a pretty uniform or stable line of CO air-free. So it basically takes you back to the point where the carbon monoxide line crosses the stoichiometric line. Okay, I'll do that one more time. So you have CO, the raw reading from the sensor, the oxygen raw reading from the sensor, and then using an equation, the meter will come back with CO air-free, which is about the same as where the CO crossed the stoichiometric line. So this sort of gives you a viewpoint going back. No matter what the level of oxygen is, you can go back and view where carbon monoxide crossed the stoichiometric line. So it's sort of like border control here. It tells you where it crossed the line, and you don't have to know. It could be at various points of combustion or oxygen levels. So this tells you the CO air-free is the point at which you have no excess air. What was that CO level? Let's go back and calculate and look at that. So the calculation here, you don't really need to know it. Sometimes it's interesting for people to know it, but the CO raw level and the oxygen level from the sensor. The CO raw level is also sometimes called CO as measured. It's the diluted value that you're measuring wherever in the ambient, in the stack, etc. And most analyzers stop doing this calculation here when oxygen gets above 16 to 18% oxygen, because the numbers kind of blow up. They get very, very large. So the CO air-free test is usually done in the stack, and it's a calculation using oxygen and CO. There's actually a spreadsheet I developed. You can go to this short link, bit.ly/CO-AF, uppercase CO dash uppercase AF for CO air-free. And you can play around with it and enter some values in, and it would do the calculation for you if you did not have a combustion analyzer that does the CO air-free calculation, which I highly doubt because they've been doing that for decades. So what do you look for in a CO measurement meter? Going back to the standard again, it's got to read up to 2000 ppm. It's got to have CO air-free measurements, which means it has to have a CO and an oxygen sensor. And this red text here is the limiting condition. You can't use a CO only meter like that Monoxer 2 I showed you before. You must have 1 parts per million resolution. That's usually an easy part of the standard met by most meters. It has to have an accuracy of plus or minus 5% of reading or plus or minus 10 parts per million, whichever is greater. And I'll show you a table in a minute that I'm developing. It's not ready for publishing yet, but I'll show you the table to point out how you would look at the specification of an analyzer to be sure that it's meeting this requirement of 7.1.2.4. Again, this red requirement is something that's going to be restrictive of some models and brands that are out there and not allow you to use them. Another restrictive requirement must be equipped internally or externally with a nitric oxide or NOx filter. And we'll explain that in a minute why that's important. It must also be calibrated in accordance with the manufacturer's recommendations with traceability of the calibration. That's usually not too hard of a hurdle for a combustion analyzer, but it's these things with the oxygen sensor, the accuracy, and the NOx filter, which will restrict or limit some brands and models of combustion analyzers for this part of the standard. So this was a test that was done where a combustion analyzer that has both a nitric oxide sensor as well as a nitric oxide filter was installed and measuring the same as a product that did not have a nitric oxide filter. So if you look at the reading here, you'll see 27 parts per million CO. If you look over here, you'll see only 6. The reason for the difference is the sensor in this device does not have a NOx filter in it, so it is not filtering out the NOx, and it's being added into the CO reading, additive to the CO reading. Over here you can see the NOx sensor says there's 38 parts per million of NOx in this flue gas stream. Now this meter does not even have a NOx sensor in it, so it doesn't know the difference. But if you do the calculation of the NOx gives about 50% of its reading to the CO sensor. So about 50% of 40 or so is 20. If you add 20 to 6, you get in the range of 26, 27. So this is why this meter reads high. It's not because this one is broken or defective in any way. This one is reading CO plus NOx. The other meter is reading CO exclusively. Now you don't have to have a NOx sensor present, but you do have to filter the NOx. NOx filters are available, built into a lot of products. There's some products that require NOx filters to be spliced into the flue gas sampling line. TruTech has a brand called Correct Measurements, a very inexpensive filter you can splice in if you're looking at getting something like that. I think they go for about $40 each, including shipping. There's also a paper on this, bit.ly/NOxTruth, all uppercase NOxTruth, that will give you some more background on this interesting feature of NOx and BPI. I'm glad they picked up on that to make sure people are giving correct readings. There's also a requirement for an ambient CO monitor. That means that an auditor must have a dedicated CO monitor when in the work environment. And the work environment is explained includes the building and any other exposure preceding entry into the building. So this was I believe this is part of the clarification statement that was made. So they of course must be operated with accordance with the manufacturer's instructions. And again, we're going to get into some specifics on that. The other details for use of these products, these test and measurement products, the conditions for entry and exit are associated with indoor air quality. You must be able to measure the CO levels and take action if required. And only after the CO and combustible levels are found to be basically safe or found to be below the levels calling for evacuation should you do any further work. So there's a stop work condition built into the standard. The instrument should be turned on outside for zeroing. Be aware of any automotive traffic or combustion outlets. Outlets for stacks or vents or things like that. The process for doing the testing, again, this is the how to, what to do, and how to do it. The combustible gas detector must be used at different levels of the home, at least one location per floor level. And if you ever see above 10% LEL, there's a notification that should be made, and the fuel gas provider shall be called. For carbon monoxide, this carbon monoxide, basically it's a personal monitor, should be on board and being used at all times by the worker that's working in the environment. They should also comply with the action levels, and there's actually stated in 7.3.3.3 of the document will state the action levels. And in quick summary, basically no work if it's exceeding 70 parts per million. In the indoor ambient, again, specifying where it should be measured, the levels. This is all spelled out in the standard. And here's some of the action levels, paragraphs taken directly from the standard. I put in red font those keywords and phrases. So 70 or greater, terminate inspection, leave the building, call emergency services. If it's 36 to 69, advise the homeowner, recommend sources of CO be turned off immediately. In the range of 9 to 35, advise that it's been detected and recommend that CO sources be checked. So that's kind of the protocol that you might be familiar with. Some of the other action level charts, these are actually put into more of a sentence structure in the new standard. So moving on to the OSHA confined space rule. So we're going to bring all these together, and we're going to converge on some solutions for you. It was actually August of last year that the new amendment to the OSHA construction standard went into effect, and it talked about residential construction, and it basically laid out the outlook that confined spaces were attics and crawl spaces amongst other spaces. And you might argue with the fact that this is not construction if you're going in after the fact and the house is built, but this talks about the construction of the building, not the fact that construction is actually going on the work site. In March of 16, the enforcement was delayed because of the confusion and the rules settling into place. And I believe this typically happens with most new rules that are out there. So they weren't really going into heavy enforcement mode. And then, interestingly, in July, just a couple months ago, the Air Conditioning Contractors of America asked OSHA, basically lobbied for some questions to be answered, some clarifications. And this next slide will explain some of the clarifications that resulted from ACCA's request for clarification. So this is actually news on the confined space rule. In July, ECA did lobbying and got extensive clarification, which boils down to minimizing the impact of this rule in residential. Now, things like there's electrical, mechanical, physical, temperature, atmospheric hazards. It focused in on the electrical and mechanical hazards that they must impede the exit, not just be present in the space. Okay, so that wouldn't make it a permit required confined space. And activities outside the attic or the confined space will rarely make it a permit required space in this interpretation. The presence of asbestos does not make it a permit required confined space. And evaluation of the space may be done remotely if adequate knowledge is present of the construction and the design of the space. You'll find these FAQs, frequently asked questions, a lot of them generated by the questions that ACA threw back at OSHA at this link, osha.gov/confined-spaces/faq.html. You want to go look at that link, and you'll see a lot of, it's actually very good plain English questions and answers to that to help people understand the standard and the interpretation of the standard. However, in spite of all that, things still happen. And that's why I think we're not going to, hopefully we're not going to take our eyes off the ball, because life and limb are at stake here. An air conditioning worker did actually pass, unfortunately, due to what they believe was heat exhaustion, hyperthermia. when he's found unconscious in an attic doing work. So it doesn't mean that you take your eye off the ball and you forget about safety because the governmental pressure is off. It's still about trying to protect people in the workspace, and things can still happen whether or not there's a piece of paper in place. So we'd like to make sure people are aware of these standards and aware of how they apply and the implications that they have. So you may have heard of permit required, non-permit required confined spaces. The permit is actually not a construction permit, but it's the permission that the employer gives the employee to enter that space. And that permit is filed at the employer's office and on the work site, so everybody knows what's going on. The permit is only required if the following conditions are present. There's a hazardous or potentially hazardous atmosphere, the potential for engulfment or suffocation. That would mean the displacement of oxygen such that you can't breathe. A physical hazard is present. So the presence of any of these items. Physical hazard is present, like temperature is considered a physical hazard, electricity, oxygen level, flammable materials, even animals or insects are physical hazards. Or physical characteristics of the space that impede entry or exit. Things like joist-only flooring, converging walls, sloping floor, different types of floor surfaces. Crawl spaces, that would be an impediment to exit because doing a belly crawl is not a quick way to move out of a space. The red areas here that I highlight are for things where TruTech can help with products and monitors for these conditions. And a hot permit does not necessarily mean a thermally hot area. It means that there's permitted entry, but there are hazards present in that confined space. And again, kind of rolling it all back to the way OSHA lays this out, try to reduce or eliminate or minimize the hazards before entry is permitted. So that's the whole goal here, is don't have to protect yourself. Where you do protect yourself or need to be aware, make sure you have that on board. And there's different situations that we all encounter. So let's get specific about the test and measurement products. There's certain gear or test equipment you may have versus the OSHA standard. We already talked a little bit about the BPI 1200 requirement, and we're kind of ending up with a hybrid solution here for you. You'll see when we get to the end here. If you try to use a combustion analyzer for OSHA requirements, it always zeroes to ambient for CO and oxygen. And by zeroing to ambient oxygen, it means it'll tell you whatever level you have is 20.9%. That's just the way they work. So that's not going to be a good solution because you wouldn't know about oxygen depletion. You would always need to have the pump on because the sensors are not exposed and external like a lot of the personal monitors are. For the gas leak detection part of OSHA, where you have to be aware of the physical hazard of an explosive gas, you probably are not able to measure LEL unless you have one of just a couple different LEL meters that we will talk about. So things like a Testo 316, again, not brand bashing here, Bacharach Leakator 10, Leakator Junior, do not measure LEL. That's just a fact. So they're not going to be a good gas leak detector to tell you how close you are to a dangerous condition. They'll tell you that a leak is present, but not how much. A personal CO monitor, again, this sort of crosses over with the BPI standard we talked about the continuous personal monitor you'll need. Personal monitors for OSHA, because the hazardous gas of carbon monoxide, be something like a Sensa P100. A lot of devices look like that. We like the Sensa. It's very rugged, American made. We know the people that make them. And it's a great brand of product, very rugged, very solid, very reliable product, and comes in different models. Non-compliant CO monitors, unfortunately, Testo 317.3, Fluke CO220, actually call it out right in their instruction manual. The Testo, do not use it as a personal safety device, and the Fluke CO220 do not use as a personal safety monitor. So you need to use the right tool in the right place for its designated purpose, Make sure you know what tool you have, and if you don't know, ask the people where you bought it from, ask the manufacturer, or ask TruTech. We'll be happy to help you out to be doing the right thing for you and your workforce. For confined space monitoring for OSHA, there are temperature hazards we talked about, and we actually do have a solution there called a hot dot. It's actually, they cost about $2 each. You can measure the physical environment, and something like wet bulb will give you a fair idea about the heat stress that could be happening. You really want to move to something called a wet bulb globe temperature thermometer, which actually measures radiant heat in addition to ambient air levels. But it all boils down to, how is your body reacting to that heat in that space? So the hot dot is a single day's use product, costs about $2. You price it on your pulse point. It actually measures with a thermochromatic, reversible thermochromatic indicator, the temperature of your body, the internal core temperature, and will warn you by turning yellow when you get to a point that you're approaching heat exhaustion. So it's a very interesting, very direct product that talks about you, the person, and monitors your personal body temperature. Hazardous atmospheres, we talked about temperature and atmospheric hazards were the two focus areas for us today. Atmospheric hazards could be detected or warned about with single gas or multi-gas analyzers, things like the Sensit P100 we spoke about a couple minutes ago, or the Sensit P400, which is a 4-gas meter, up to 4 gas. The typical gases that we see happening in the kind of work that you'll be doing are carbon monoxide, oxygen, explosives, or as displayed by the LEL, explosive or combustible gases, and perhaps hydrogen sulfide in certain conditions if you're working around any kind of sewer, waste, sump, septic, where that could build up. H2S is a sensor that could be added to this device or bought in that configuration. So if we talk about compliant, BPI 1200 compliant combustible gas detectors, we've really found just two. I mean, there's actually a couple more, but the price ranges start to jump up. So these are the two most economical ones, and we sell them at TruTech. It's a Sensit HXG-2D, and it's a very purposefully designed product. It's intrinsically safe. It has the LEL display. It has the alarm built into it. It has the gas leak, the zeroing capability, the tick adjustment, everything you need to do gas leak detection as well as protection from explosive environments. The EXCO Plus 1200 is actually the big brother to the HXG2D in that it combines all the features of that, plus it actually covers the BPI 1200 requirements. And in terms of doing the gas leak detection, the CO air-free or combustion test, and also doing the oxygen depletion for OSHA, the LEL for OSHA. So it's a multi-purpose meter that covers the OSHA requirements and the BPI requirements. Keep in mind, if you do have your authority saying you have to do more than BPI 1200, make sure you understand what's on your checklist and you pick the correct device. But this EXCO Plus 1200 was designed specifically for the purpose of complying with the OSHA and the BPI 1200 requirements. I'm going to jump to a chart now. Again, this isn't ready for publication. Unfortunately, I can't share it with you yet. I want to make sure the manufacturers have a chance to see it and BPI has a chance to see it before I share it. But this is a work in progress for the BPI compliant combustion analyzers. I will give you, here's a picture of the compliant combustible gas detectors for 7.1 of the BPI standard here. So the Sensit EXCO Plus, the HXG2D, actually the HXG3, which is sort of a higher level than the HXG2, the Sensit Gold. These are all compliant with all the specifications, as you can see, and they're all available now. And this is the red zone here is where these analyzers like the TKX does not have a display, so it's not compliant with BPI. The Leakator 10 does not have display. The Sensa 316 is not intrinsically safe, although it does have a 10% LEL alarm. And these two products I haven't fully evaluated yet for those conditions. So that's sort of the matrix of how things are developing, working off the manufacturer's information. For the combustion analysis, the Sensa EXCO Plus 1200, that does comply with the 2000 ppm. It goes right down the list of every component here of the BPI 1200. The PCA3 also complies. The PCA2, it's no longer made, but you may have it and keep it in use. That complies. The PCA, the Insight Plus is also a compliant product that's available now. Moving to the right here, again, this is not fully ready for sharing yet, but the Insight, I have to complete this standard, so don't take it for Bible quoting chapter and verse. But we'll be moving these products over to the cleared side once we provide information. But you can see there's an awful lot of them, so the work has been done up to this point. If you have a question offline, feel free to ask it. For the ambient CO, here are the actual specification for it. Here are the action levels, and the ones that we found in Cell are the found available are the EXCO Plus 1200. Again, that's the multi-purpose, the Sensa CO, Sensa P100 CO, and the CM-1. The Bacharach Sniffit Plus is also available, but you can see we'll be reading out those that do not comply with the standard, and we're going to work through this list to make sure this is available. If you're curious, we didn't cover the depressurization standard, but basically you've got your manometers are all compliant with the standard here. I will fill this table in and make it complete, but there's no concern here with the Energy Conservatory Retrotech manometers being compliant with the resolution standard. They're all designed to meet that. So thank you for the feedback, Kelly. Going back to presentation here. So again, this is sort of the intersection or the nexus of all this is the Sensa Gold EXCO Plus 1200 meets both the OSHA confined space rules for the construction industry, is typically embodied by the work that people do in this business, as well as the BPI 1200 standard. So everything's on one screen. There's only one display. It comes with probes and filters, so you can do the confined space entry pre-screening if you need to. It's filtered so it won't absorb water through the probe tip. It's got a hydrophobic filter in it. It's got the NOx filter in it for doing the CO air-free test. Continuous pump and combustible sensor. The sensor's in the tip of the probe, which is a real benefit in that it responds very quickly. That's where the gas is going to hit right there immediately. So in its hybrid mode here, it covers the BPI standard for the LEL display and also for OSHA, the OSHA standard for oxygen, BPI and OSHA for CO, the CO air-free spec for BPI. It has the alarms that BPI and OSHA require, the oxygen for OSHA, the carbon monoxide alarm for BPI and OSHA. And on top of that, it gives you stored test data with a time and date stamp, and the last 10 tests can be printed through its infrared port onto a testo printer. So again, we've kind of taken this, we're going over time a little bit here. Actually not, still under time. We've taken this to the next level and really analyzed closely and work with BPI to understand that they do require that personal monitor always be on and running, and you may not have it running when you're doing your combustion safety tests. So you would need to have sort of the dynamic duo here of the EXCO Plus and the personal monitor. This would meet the minimum requirements, the full minimum requirements of the BPI 1200 standard. So you get the combustible gas detector with LEL display, the CO air-free with the NOx filter, and the continuous personal monitor all available. And then for OSHA, this does have actually built into it, it's got 3-gas monitor with the pump. So it does the oxygen, CO, and LEL, and has the pump built in to allow you to pre-screen a confined space before you enter it. So we really proud of getting that together and getting the great folks at Sensit to help us create that kit and provide it a very affordable price of just under $1,200. And that's the web link for it, BPI OSHA Basics-Kit. If you go to TruTech Tools, you can find it there. And I wanted to wrap up here, see if there's any questions, but did want to make an offer of an additional 6% off for those that are listening to this webinar. If you use the code 6, BPI6 at checkout, for any product, but you could use it if you're especially looking to kind of get your arsenal of tools and test gear in line with the BPI and OSHA standards. We do have those products available for you. Also, feel free to call us, visit our website, drop us an email, info@TruTechTools.com. We'd be happy to help you out selecting and understanding the products that you need to take care of the work that you need to do. So I haven't seen too many questions here. I guess I've done an excellent job. Are there any questions out there? Somebody raised a hand for a quick second. I'm not going to turn the mic live because they don't know about background noise. Andrew, would you mind typing in your question? Okay, got a good one from Kelly. Have I heard of anyone enforcing tool requirements yet? No, I haven't. I haven't heard that. I know people are becoming aware of it. It's within the authority that requires the use of the standard to enforce it or not. I haven't heard anything specifically come my way. Okay, Andrew. He was just waving by raising his hand, saying hi and thank you. And Emmett, thank you for the feedback and compliment. How often is factory calibration required? That's usually something that the manufacturer will specify. Typically, it's annual calibration. Some of the products you can actually buy cal kits, you can get replacement sensors, or you can use the manufacturer third party. TruTech Tools does provide the third party service. The Testo 327 I do not believe is compliant. It fails on the CO accuracy specification as specified by the manufacturer's literature. And when I do have direct confirmation of that, I will be sure to get this list out into the public domain. But my initial look at it is that all of the Testo analyzers fail the accuracy spec. Suresh is not clear about OSHA permit required space. Okay, going back, a permit is required if you know you have a hazard present. It can be a confined space, has a definition, something that's hard to get into or out of, something that has hazards present, could have hazards present. The construction of the space makes it a confined space. Permit required means you're operating with a known hazard present, and then you have to have a protocol in place to make sure people are protected and able to be evacuated from that space. And again, the goal is not to have a permit required space, but it's to have a space that's been cleared of any potential hazard. I will be doing a webinar specifically on OSHA confined space rule. We'll get it out through email and through our social media, so be looking for that. We'll have to look and see if I can get BPI credits for that or not. Someone asked that question already, Eric. 327, I do not believe meets that requirement, and it fails because of the accuracy specification for the CO reading. Kelly says a lot of tools may become obsolete. Any news from manufacturers offer booster kits or something will make existing combustion analyzers, CGD, or combustion analyzers or combustible gas detectors compliant. Myself, having worked for two manufacturers for over 20 years, I know that's a difficult thing to do to retrofit because usually the instruments are made purpose specific with certain price points and manufacturing goals set in mind. I do not believe that's going to be possible from anyone. It would have to be a product that either existing qualifies or a new product that would qualify. So unfortunately, that's not the case. The new standard will require the churn of a toolkit. You're welcome, Eric. How often will we see OSHA? I guess Sure asked, how often will we see OSHA requirements? You work in an energy efficiency company. It really depends on the situations you work in. Again, that's where I would have a real close look at those links that I shared, the OSHA FAQs, and determine, your employer has to determine if the workers will be exposed because they are responsible for that. So it's a determination the employer has to make. James, thank you for the compliment. Thank you, Michael. And question, does TruTech take trade-ins of equipment for upgrading newer tools? Unfortunately, that's not something we usually participate in. Very, very rarely do we, but it's a very hard thing to take something that's moving into obsolescence and to be able to sell it at a price. I would suggest you might want to try something like eBay or something like that and see if there's someone who is not required to be in compliance would want to use the product that you have on hand. You're welcome, Alan, and Suresh, thank you. Okay, I'm going to wrap it up here. Gone just over the 2 hours or hour. Still see some hands up. Just assuming people are still waving at me. Your arm's going to get tired if you keep waving that long. Okay, I'm going to close it up now. Again, any questions, call us 888-224-3437. Drop us an email, info@trutech.tools.com. And please take advantage of the coupon code we have here if you need to get your toolkit in compliance. Thank you, everyone. Have a great day.